So this video is requested by one of your compatriots, and the idea here is that we're going to have to probably use a couple different techniques to get through this. And so the request was to do it while switching the limits through the whole thing. I think that's what they're asking for. So first of all, because it's x squared plus 4 underneath the square root, we think of tangent. So the first sub is going to be x equals 2 tan theta, which means that dx is equal to secant squared theta. But when we do that, if we want to switch the limits, you've got to create the new limits. So when x is 0, we would go 0 equals 2 tan theta, and we'd have to solve for theta. So we divide both sides by 2, and we get 0 is equal to tan theta. And you take the arctan as 0, so you're asking when is tangent 0? That would be when sine is 0, which would be 0. So 0 for x is still going to be 0 for theta. But if we do the same thing, put a 2 here, divide both sides by 2, and we get 1. When is tangent equal to 1? That would be at pi over 4. So we put a pi over 4 up there. So now I don't have to switch back to x. I can just leave it as theta. So then I'm going to go ahead and make my substitution. So that would be 9 times, and I'm going to take x cubed, so that would be 8 times the tangent cubed x. And then inside the square root, I'm going to have, 4 tangent squared theta plus 4. And then out here I'm going to have, I don't know why I'm going up with that. Let me start that over again. So this would be 9 times 8 tangent cubed times the square root of 4 tangent squared plus 4. And then dx is going to be replaced with 2 secant squared theta d theta. Okay? Now we'll try to clean this up a little bit. 9 times 8 is 72. I'll take that outside. Oh, and then another 2. That'd be 72, 144. So I'll do 144 out here. And that would be tangent cubed theta. Sorry, that x slipped in there. And then this is going to be the square root of 4 times secant squared theta times secant squared theta d theta. Okay, so we got one more 2 to come out here, so that would be 288 integral, and this is still 0 and pi over 4. 0 and pi over 4. So then that becomes tangent cubed theta secant cubed theta d theta, because this secant, the square root of secant squared is just secant. Secant times secant squared is secant cubed. Okay, now we're going to do another substitution, because really the way to finish this off is using u substitution. So then I'm going to let and these are kind of the tricky ones where my suggestion is you look at this and figure out what would a du be that would work. In other words, if I make, for example, du equal to secant squared, that means that u has to be tangent squared, right? And that's a problem, because if I pull out a secant squared for the du, it leaves only one secant left over, and I won't be able to change that to tangent. So instead, what I want to do is I'm going to pick my du to be secant theta tangent theta d theta, which would mean my u has to be secant theta. So I'm going to rewrite this as 288. I'm just taking kind of careful steps as we go. So that means that I'm going to have a tangent squared theta, secant squared theta, tangent theta, secant theta, d theta. And I'm writing it like that so you can see that this whole thing here would be my du. This will easily be written as u squared, so I need to change that thing. Okay, and of course we change that because we know that tangent squared theta is equal to secant squared minus 1. So then I can rewrite this as 288, leave the limits alone for a second. And that circled thing is going to be replaced with a u squared minus 1 times a u squared, because of the secant, du. And now our second change of limits. So again, we're going to say, okay, when theta is pi over 4, what is u? Or when theta is u, what is, when theta is 0, what is u? And when theta is pi over 4, what is u? So when theta is 0, that would be, whoops, secant of 0. Well, cosine of 0 is 1, and secant is 1 over cosine, so that would be 1. So that means this is going to be 1 down here. And then when I plug in pi over 4, okay, so then secant of pi over 4, that would be 1 over rad 2 over 2, which would be 2 over rad 2. Or actually just be rad 2, wouldn't it? Just be rad 2. Because cosine of pi over 4 is 1 over rad 2. Flip it over, it's rad 2. Yeah, okay. So then we'd have a rad 2 up here. Okay? Then again, we don't have to switch back when we're done. So now we can go ahead and integrate this thing. So we have 288, integral running from 1 to rad 2. And that would be u to the 4th minus u squared du. And of course, that's going to be 288 times 1/5 u to the 5th minus 1/3 u to the 3rd, evaluated from 1 to rad 2. And that's going to be 288. And if I plug in a rad 2 in there, that would be the 2 to the 5/2 power over 5 minus 2 to the 3/2 power over 3. I plug a 1 in there, and that'd be minus 1/5 and plus 1/3. And of course, you could simplify that a little bit, or you could throw the whole thing in your calculator and estimate it, but that would be your final result. All right, hopefully that was helpful.